All right, next up, we have Kristoffer Carlsson talking about app support in Pkg. Take it away.
Thank you. So yeah, the main focus here will be app support in Pkg, but I managed to squeeze in 2 bonus features that's been in, so I'll talk quickly about those first. So the first one is this new sources entry that can be put into project files. So just a little bit of background here. So the project file, as you know, it contains sort of required packages, those that you need to have. And it's sort of an input file. And then you have the manifest file, which is an output file from the resolver that contains the set of packages that are all compatible with each other and all the dependencies are there and so on. And information about the set of available versions, dependencies, and all the compatibility is available by the registries. So the default registry in Julia is general, but you can also add in more registries. But you can also add packages by URL or by path, which we call the dev package. And in that case, you don't use the registry to look up dependencies or compatibility information. Instead, you look at the project file of that specific package. And the information here, for example, the path of the package gets stored in the manifest file, so that next time you do a Pkg operation, you know that path and you can look it up. So we said that the manifest file was an output file, but now we're kind of using it as an input file as well to read the path, so we can sort of feel that something is maybe not 100% right there. But the version of packages that you add by URL or by path is sort of frozen. Those are fixed, but the other packages can be, you know, the version can vary. So unregistered dependencies then are packages that are not in a registry. And we need to either provide a path to those packages or a URL so we can download them and read their dependencies and compatibility info. But right now, they're only storing this URL or the path in the manifest file. So if we don't have a manifest, we cannot read information about these unregistered packages. So if we delete our manifest, for example, that's very annoying, because then all of a sudden we have to manually add back all our unregistered dependencies. If we have a lot of packages that are using the same unregistered dependencies, it's also annoying, because you have to add all these unregistered dependencies one by one. It's possible to use this local registry, but sometimes that's a bit overkill. So the simple solution here is just to allow specifying URLs or path in the project file as well. So that's what sources does here. So I'm printing out here a project file. And then there's this new sources entry that has a URL to a package and also a path to some other package. And you can see now I nuke my manifest file, but now I can still instantiate this project because the information for where to look up these packages are there. This is kind of obvious in hindsight. Maybe they shouldn't be stored in the manifest in the first place, but at least now things are the way they should be. The second little feature then is called Workspace, which will be available in 1.12. So right now there's a little bit of a manifest mania, I call it, in that each project file requires a manifest file to know sort of what versions you should load for that environment. But each manifest file can only provide package versions for a single project file. So every package, you have a project file there and it requires a manifest. If you have a documentation project, it needs a manifest. If you have a benchmark project, it needs a manifest. So it's a little bit like this sometimes, where you have these manifests all over the place. And there's a bit of a problem with that, in that a manifest is sort of a source of truth. You know, it says what versions you're going to load. And if you have all these manifests everywhere, it's very easy that they become out of sync with each other. And maybe in this package you're loading one version, in the other one you're loading another version of a dependency. But sometimes you kind of only want to have the same package versions for a bunch of projects. So the idea then is, could we have one manifest that's sort of used by many projects? And that's what a workspace is. It's a collection of project files, but they all share a single manifest file. So when you do a resolve in a workspace, you go through all the project files and collect all the packages. You intersect all the compatibility constraints. And then in the end, you do a resolve and you produce a single manifest that will be next to, it's called a root project. I'll show a bit later. And in that single manifest, then are all the packages of all the projects, and all the package versions will be compatible with each other. And as a consequence of that, many Pkg function now takes you can take a keyword argument, workspace is equal to true, or if you're using the REPL, you can use -- workspace. So if I do Pkg precompile, maybe I want to precompile my whole workspace, or just sort of the specific object, and the same with the status and the Y and a bunch of other APIs there. So as an example here, let's say we have what I call a mono repository here, where we have some project packages in there. We have a project.toml there in the end, and we have a manifest, which will be the single manifest of this whole environment. So if we look in this project file, then we have this new workspace section. And in that, we add what projects should be part of this workspace. So now if I do status with the -- workspace here, it's going to show me many project files. All of those are included in the workspace, and then all of the packages that are included. And if I activate one of the projects inside this workspace, you can see that Pkg REPL is a little bit different. It shows you that the mono repository here is the root project name, and then you have the private package, which is part of that workspace. And you can also nest workspace. So if we, inside one of these packages that were part of the workspace, also have another workspace, for example, the benchmarks here, and if we activate that, we can see on the REPL that's also part of the workspace. So if we go back here, even the project file inside the benchmarks folder there is part of the workspace, so it's not going to have an associated manifest. So all of these packages in all of these projects will end up in one manifest. And that's convenient for if we update something, we get the same. We only have one place where the versions are stored, so there's never any case where things become out of sync with each other. So that was the 2 bonus feature. Now let's talk about the main thing, which is called apps here. I don't know, we can also call them programs or executables or command line tools. There's many different names. Apps is kind of short and sweet, so that's what I'm going to use. Just want to state here that this stuff is not in any release or pre-release, so things can change. So when we talk about apps, let's think what is an app and what's a library. What are the difference between those? So one thing is sort of the entry point. In an app, we start at main, sort of. In Julia, there's a new convention where you put function and you have this main macro. It sort of defines saying that, okay, this is where you will start executing. But with libraries, there's no defined entry point. You just call a function there. Maybe you need this one. Some other package maybe calls another one. That's one difference. Another thing is how they're executed. Apps are typically called by their name. It could be from the terminal. I mean, you could run an external command inside from Julia, while a library just load them into your process with, you load a package and then you start calling things. Now the difference is with the memory. With an app, they have a separate process. It has its own address space. It's sort of contained there. While with libraries, you share the memory with all the other libraries you have loaded. When it comes to dependency resolution, apps, since they execute in their own isolated environment, they don't have to think about compatibility with other things that's going to get loaded. So they sort of are resolved on their own, have their own dependency graph, which is independent of other apps you might want to run. While libraries, they are sort of interacting with each other in the same environment. So all of those are going to have to be resolved together. In some sense, we can say that all Julia packages now are kind of libraries, because you kind of always start Julia, and then you load them. And then they might have sort of like a main function, like Pluto.run or IJulia.notebook or Franklin serve or something. But it would be probably nicer if you could install Pluto and then just write Pluto at the command in the terminal and have it run instead of having to start the Julia REPL and do this little mini startup thing. So let's think about how we should structure a Julia app then. So a good idea is to start with having as a package. So we have a standard project file. We want to have a bit of extra information. So we want to have the name of the executable. We still can have dependencies, compatibility, and maybe we want to specify exactly what version of the dependencies we want to use. So we can add a manifest in there as well. Here, there's this new app section, which has the name of the executable, And there's possibility they're putting some metadata in the dictionary there, but for this case, there's nothing there, so it's just an empty dictionary. So if we look at the content of this app, then it's called rot13 because what it does is it rotates every letter, 13 steps in the alphabet. And the point then here is we have this @main function. That's the execution point, and it loops through the arguments, and it does this rotation. And there's this new -m flag we can use to execute an entry point. So in this case, if I'm inside this project, I can run with the -m, say the package name, and then give some arguments. But we kind of don't want to have to start Julia like this into the -m flag. We want things to get installed for us, so we can just write the name of the app. So let's go further. So what do we need to do to install the Julia app then? Well, first we need to get it from the internet to our computer. We need to get the source. And it's a big overlap with installing packages here, so this is probably best handled by the package manager. It gives registry support, Pkg server support. We have the REPL syntax, auto-completion, and so on. There's a lot of conveniences in there. Then we have to store the app somewhere on our system. But since the app is kind of the same as a normal package, we can just use exactly the same storage scheme. We have to install the dependencies of the app and store this resulting environment somewhere. So we could have a special environment folder called apps, and then we have the app name folder in there, and there we store the project and the manifest file, which is the resolution of that app. We should precompile that environment. And then finally, we need to create this shim that actually launches the app, which needs to be in our path folder. So as an example here, we have this little bash sim. If I print it out, it sets the load path to where this environment got resolved. It does the -m thing for us. It does the package name, and then it passes the arguments. And we also want to keep track of what apps are actually installed. So we have sort of the same as we can do package status. We read the manifest file or the project file, and we can see all the packages that are installed. So in the same way, we want to keep track of what apps are installed. So here there's this new app manifest.toml in the apps folder in environments, and it keeps track of all the apps that are installed. Now it's just this rotate13 one. And there's also a list of all the executables provided by that package. And you can also see here we stored the Julia command that's going to be used to run this app, and also the Julia version. I'll come back a little bit to this Julia command, what Julia version is used to run it. So then there's some new Pkg commands, and there's a new submodule, Pkg.app. And we also have this app prefix in the REPL. So we can add an app with app add, or we could delete it with app rm, and there's app status, app update, app precompile, and so on. So kind of like all these package API we had, but now we also have one for apps. So let's do a little short demo then how this would work. So first I clear out my .julia bin, I clear out my environment thing so that I'm starting off at a clean slate. Then I do app status. It doesn't show me anything because nothing is installed yet. I try to execute this route13 command. There's nothing there yet. OK, good. So now I do this app add command then, and I give it a URL, same way you would do for a package. So this is an unregistered app then. And it's going to do these steps we went through. It's going to download it. It's going to put this project into this environment apps. It's going to precompile it. Now everything was already precompiled. And then it's going to create this shim so we can just run it. So now when I do the shell after this, I can just run this thing with rot13 ABC, and it rotates those letters 13 steps. So instead of having this be rot13, we could be Pluto or something, and we just write app add Pluto, and then after that we can just run Pluto in our command line. Now when I do app status, it looks in this app manifest.toml, and it shows us, OK, this is the package we have, and it provides this lower case executable, rot13, and it's going to be run with this Julia command. And I can delete it, and it said it deleted all apps for this package, and this is the particular executable deleted. And now if I do status, it doesn't show anything there. So we kind of added, executed it, and removed it. OK, everything looks good then, right? Well, so why isn't this sort of merged and ready yet? Well, there's quite a lot of complications I found out that made things tricky. So for example, what Julia version should be used to launch the app? There's like many right answers. You could have the latest compatible with the Julia compat of the app. Like if the app says, I'm compatible with every Julia version above 1.8. Shouldn't you want to use the latest one then? Maybe. Maybe you should use the one that installed the app. Like if I'm use this specific Julia version to install it, maybe that's the one we should use. In the bundle manifest, there's also a Julia version entry that says what Julia version was actually used to generate the app. So maybe the author of the app should have the decision there. And it's also, should this be integrated with Julia Up? So if I change my Julia version with Julia Up, or maybe I update it, should these apps sort of move along with that? Another thing is, should you be able to have multiple apps in one Julia package? Right now, with my previous example, I just had the main function in the package module. But maybe you want to be able to provide multiple executable in the same package. So then you could maybe have different sub-modules with different main things in. Or maybe in different individual files that have main functions. But then those need to be compiled separately, and it's a little bit tricky. Should a manifest file be required so that the app author says, like, OK, these are the versions we're going to use, and that's it. Those are the ones we use. Another thing is that JLLs can provide executables. And it would be nice if we could also install those as apps. So we can have a little Julia distro almost, where we download our command line tools, not only the Julia ones, but also the ones that are provided by the JLLs as apps. Should there be some naming convention? Like if you write add something, how do we know that that provides an executable? Should it be forced to end with the app there or not? Can a package be both an app and a library at the same time? So let's say Pluto, right now it's a library. It probably wants to add a main function. Should it need to add a new package like Pluto.app.jl, which has the main function, or could those be in the same package? Should apps be able to customize arguments to Julia? Maybe this is like an app that wants to run multi-threaded, then maybe it should be able to say that, OK, I want to run with all threads or something. I want to run with a high optimization level. There's also this XDG compliance that people says that, oh, you should install binaries to .local bin. But typically, Julia hasn't really followed that so much. It keeps things in .julia. We have precompiled files that can get evicted. There were precompiled files in Julia. It's like a cache. But after a while, if there's enough of them generated, it's going to start deleting the old ones. But it could be kind of annoying if you want to run your command line thing, and it's going to have to start precompiling things again. There's also, what should the exact interactions with depot path be? If we go back a little bit, you see I installed things in .julia environments. That is .julia is the first entry in the depot path. But what if that gets changed? So you run with the custom depot path. So that's, I would say, why this is not merged yet, even though the basic usage works pretty well. So I think we just have to go kind of through this one by one and take the easy path, and then depending on sort of experience and so on, try to know what the best answer to these questions are. Yeah, I think that's actually all from me, so I end a bit early. Thanks.
Thank you so much. Let's have questions. Right up there.
So with the package REPL, you have app add. Why did you choose that design over just having add and then having something in the project that indicated there was an app inside of it?
So the question is here, why app add and not just do add and then deciding on the project file, which would happen. I think I wanted it to be explicit from a user point of view that this is going to like add a new executable to your system. So that's why this was separated, and it felt like it would be needed for like status and the other things as well. So that's why it felt like symmetric to also have app add.
Okay, I was just thinking having one may be better for combined libraries and applications.
Yeah, so if there would be combined libraries and application, let's say the Pluto example, what it would do in this case, if you just did add Pluto, it would just get the library. And if you did app add, you mean like, OK, I actually want the Pluto executable to be installed. Of course, if you just did add, then maybe it should install both the library and the app. But the thing is, the app is kind of independent of your current environment. But the library is not independent of your current environment. So if you in one single call both do like a global change, which is the app, and the local change, which is the library, I don't think you want to do that so often, maybe. Like, I would say for the Pluto case, you very rarely want to add it as a library. It's kind of, yeah.
I think you definitely made the correct choice here that app add should be completely separate from adding a library, because in Conda I've seen this go horribly wrong. In Conda, when you install a package, they add lots of binaries. And the most famous one is in Conda, if you have Kerberos as a dependency of something you didn't even know you wanted, then they install a new kinit program for you. That overrides on macOS the different kinit from Apple, and it wrecks your entire Kerberos functionality, and kinit no longer works. It's a very common user support problem that people have installed binaries that override system binaries of the same name without actually knowing it. So I applaud you for having app add separate from add too.
Okay, thank you.
I'm in on that.
Lots of fun stuff there. So question about source. So it looks like you specify either a URL or a path, but presumably when you instantiate, the URL will get turned into a local path. Is there a syntax for making sure you reuse the local path in which something that's installed from a URL occurs across packages?
So one comment was that when you have a URL here, it can turn into a local path when you install it. Yeah. Actually, what's end up in the manifest when you add something with a URL is the git tree SHA one. And based on that, Julia computes a path. But that will be based on your current depot path. So you will not have an actual path there in the manifest. It will just be a hash entry, and Julia will know, like, OK, I'm going to look through all the depot paths to find that hash entry. Could you repeat the second part of the?
Oh, I was just wondering, so if you have multiple packages that use the same environment graph source, are there protections against making sure that you don't have many different copies of the same URL checked out?
So one thing to comment here is that this sources section will only be used if this is your active project. So if you have a dependency with the source entry, it's not going to be used. So you have to have this as your active one. There's also some checks that goes through if you have multiple sources that it's going to be the same one, basically. So it shouldn't be the case where you could get confused which one it's using.
Sorry, I might just jump in here. Yeah, this is great. I've wanted to have apps, so thank you. My question is about the naming of @main. Why is it not just a normal function name that the user, any function that the user would like to call it, with an annotation out the front of that function? And how does the user test that function? Say they want to test it from the REPL, calling the main function, so things don't have to be reloaded every time. Yeah, how do you do testing of that entry point?
So basically what Julia does now is when Julia exits, it will check if there's this type of @main in your main module, and if it is, it will execute it with the arguments. And the reason why this main was specifically chosen instead of just that you could specify it in the project file or something like that was just, I think it was just a design decision. It was decided that we should have a single name, and if Julia exits while this thing is defined in your main module, it will run that function. So, yeah.
Sorry about that. Quick question about the workspaces that you showed.
Yeah.
Does this work with the testing suite?
Yes.
Yeah, okay.
So if you have I didn't have that here, but if you have a test folder with the project in, those are also going to be put into this manifest. And when you run Pkg test, it's going to see that, okay, this test is actually in a workspace, so I'm going to use this manifest. So yes.
Hi, thank you for apps. I've been looking for this as well. I was wondering how just-in-time compilation works and whether you can use a system, I think somebody talked about it today, like static compilation using Julia-C, so that, for example, when I create GUIs using Julia, you know, when you first load up the GUI and you press a button, at the moment my app, it's like the first time you press a button, there's this lag, and then there's the just-in-time compilation, and the user's like, what's going on? Like, why is it not working? And it works the second time. But you have to be patient the first time.
So the question is about pre-compiling apps. So one thing to try do, it's kind of tricky with GUI apps, because typically how you pre-compile right now, a normal package in Julia is to you have a little workload that you run. And this is sort of a workload that gets run, and you collect, based on that, you see which functions actually end up getting compiled. And those are going to get stored in your package image. And when you load that package image, you have the compiled code already there. Now, when you have a graphical user interface, it's a little bit trickier, because you want to sort of automate that process. And maybe you actually want to have to click the mouse and so on. So I guess how to do that is you would have to have a compiled workload that's going to end up executing the same thing as someone would press the button when the GUI is actually running. And other than that, there's no difference pre-compiling an app from a package. And I know, so yeah, I would say you would have to do the same as you would want to do with a package that you want to have a good pre-compilation for. Have like a representative pre-compiled workload that gets run during pre-compilation of the package. And yeah. I think that's the way it has to be done.
We have time for one more question.
I'm looking forward to Kristoffer other side.
Oh, there.
I'm looking forward to all of these features. So 1.12 next LTS. But no, could we also put into sources custom registries as sources of truth?
Yes, so that's one thing now, is that there's nothing, not the project file nor the manifest file, that stores the set of registries that were used to resolve this environment. So if you're using multiple registries, it's not enough to send your project and manifest file to someone, because it's only going to download the general registry, or it's already going to be there. But then it's going to say, like, wait, this dependency, I can't find it in the general registry, so you somehow have to manually say, like, oh wait, for this environment you need this specific registry as well. And that's a little bit of flaw about that. You should only need the project and manifest file to have this total reproducibility, but there's actually a bit of information lacking there. So I think there's two things that can be added. The first one is in the project file. I'm not sure it should be in sources. Maybe there should be a separate one saying like which registries to use. But maybe also the manifest file should include what registries were used to resolve the environment. So then you would just send your project and your manifest file to someone, and those registries that were needed to resolve this environment would be stored in the manifest and could be downloaded for the next instantiation.
All right, thank you so much. Let's have another round of applause.